For centuries, the limit of human knowledge was defined by what we could see with the naked eye. To early astronomers, the glowing band of the Milky Way was the entire universe. That perception held until 1924. Edwin Hubble used the Hooker telescope to identify specific, variable stars within distant spiral nebulae, objects previously thought to be mere clouds of gas within our own galaxy. By calculating the distances to these stars, Hubble proved they were far too distant to belong to the Milky Way. They were members of entirely separate galaxies, existing millions of light-years away. This shifted our understanding from a universe of one galaxy to a universe of many. It left astronomers with a new, deceptively simple problem: exactly how many galaxies are out there? In 1995, we attempted a definitive count. The Hubble Space Telescope stared at a single dark patch of the sky for 10 days, capturing light from galaxies that had never been seen before. Based on those deep field observations, astronomers calculated that the observable universe contained roughly 120 billion galaxies. Recently, researchers conducted a new analysis of that legacy data. Instead of counting only the visible light in the images, they used mathematical models to infer what might be hidden in the noise. The analysis concluded that the 120 billion figure was low by a factor of 10. This suggests that 90% of the galaxies in the universe are too faint and too distant for our current telescopes to detect. This creates a massive gap in our maps. Our most advanced deep space observations have effectively missed the vast majority of the universe. To find those missing galaxies, we have to look back in time. Because light takes time to travel across the void, looking deeper into space means observing the universe as it existed billions of years ago. This timeline reaches back 13 billion years. Our visibility is limited by the cosmological horizon, the distance light has traveled since the universe began. The missing galaxies are hidden in its furthest reaches, their light too faint for current instruments to resolve. Since we cannot see them directly, astronomers use calculations to fill in the gaps, modeling the conditions of the early universe based on the physics of light and gravity. These models show that more than 13 billion years ago, the universe was far more crowded. The galaxy density during that era was 10 times higher than in our modern neighborhood. This crowded, ancient environment holds the key to the missing 90. Over 13 billion years, gravity pulled these small, tightly packed galaxies together. They collided and merged in a continuous process, with trillions of small building blocks combining to form larger, more complex structures. As these galaxies merged to become larger, the total number of individual galaxies dropped. The missing 90% were physically consumed. They became the massive, modern galaxies that we are finally able to observe. The 120 billion galaxies we can see today are the survivors. They are the final products of 13 billion years of galactic mergers. This applies to our own home as well. The Milky Way is a composite structure built from the remnants of the ancient dwarf galaxies that used to fill the early universe. We are developing new ways to witness this history. The James Webb Space Telescope uses a massive hexagonal mirror array to capture the faint infrared light from those ancient, hidden galaxies. On the ground, powerful observatories in the Chilean Andes are also searching the southern sky, using the world's clearest atmospheric conditions to track galactic evolution. The night sky is an evolving record of destruction and creation. Every star we see is a small part of a larger, ongoing history that we are only beginning to decode.